This tutorial is on the subject of ideality. Ideality is a TRIZ concept. TRIZ is a Russian acronym for the theory of inventive problem solving. So what you'll learn on this tutorial is what ideality is and why it's important to your customers, how ideality and this concept of value relate to each other. You'll learn 6 strategies to improve ideality and create a more ideal system or process. And you'll see several examples from different industries to illustrate these 6 strategies.
So the first thing I want to start out with is letting you know that this is not really a tool. It's more of a concept. It's more of a goal or a vision than a tool. And now most of the videos and tutorials that you're going to see here are based on tools where you can actually use somewhat of a structured method to accomplish a goal, but this one's more of a concept. If I were to ask you which car of these 2 cars is a better value, a $12,000 smart car or a $68,000 Audi? It's a tough question to answer because some people will pick the smart car and others will pick the Audi. And the point I want to make here is that value is really not about price. It's not solely about price. Actually, price is a component of value, but it's not about price. There's 3 equations I'm going to show you for these concepts, and I like to show you them in good, better, and best. A good formula for value, and this comes from the Society of Value Engineers, SAVE, and it is a ratio of function to cost. A little bit better formula I've seen in an innovation software where they actually calculate the value of each of the components of a system, and they use an internal algorithm, but it's basically the formula of function squared over problems plus cost. So they add another dimension here as problems in the denominator. And I think maybe the best definition, and this comes from TRIZ, the definition of ideality is the sum of the useful functions divided by the sum of the harmful effects. So if you think about it, all 3 of these equations are really saying the same thing. They're saying that value and ideality is a ratio of good to bad. So here's another way to look at it. If you look at your goal of maximizing ideality, and you have a current system, system A, and that current system has inherent problems and it has challenges and it has constraints, but it is the system A. What we normally do when we try to improve things is we take our current system and then we try to improve it. Okay, we go from system A to system A prime. Ideal final result type thinking is, instead of starting with your current system and just trying to improve it, it says, let's look at an ideal system. Let's try to define what the perfect world is for this system. So given that we understand the concept of value and ideality and the equations or the formulas, there are 6 different things that you can do to improve value. The interesting thing is people don't think of all these 6 different ways to approach value. As a matter of fact, people think that the main thing that you have to do is just get rid of cost. Instead of a 5-function system, I'm going to offer a 6-function system at the same cost. If I can do that, that's better value. Obviously has one main function, which is to hold books. But let's take a look at this one here. So this is kind of a unique bookshelf. And if you want, you can pause the tutorial and see if you can figure out 4 functions this has. One is obvious, is to hold books. The second one is pretty obvious too, which is to illuminate the book. You know, there's a light involved in this additional function of that bookshelf. And the third one, to the cooling things. You know, there's mechanical ways to cool things, there's electrical ways to cool things, there's chemical ways to cool things, there's acoustical ways to cool things, there's optical ways. So there's lots of different ways to perform a function. Then there's strategy 6. Can you take function out and still improve value? And the answer is yes, if you take out more cost than you did function. So here you want to decrease the denominator more than you've decreased the numerator. Ideality is the sum of the useful functions divided the sum of the harmful effects, just like this equation here, which is very close to the concept of value, which is function over cost. Both of those are really saying a ratio of good to bad.